Okay, we've talked extensively about data frames, but let's quickly review it. You can create a data frame with the data frame function, and then you supply the columns yourself. So an example of that would be you have a vector like this, another vector like this, another vector like this, and then you use the data frame function with the first vector, the second vector, the third vector, and the fourth vector. I forgot this was the first vector. Okay? And then if you print it out, you'll see this as a data frame. And the advantage of, we've said numerous times about data frames, is that you can have different types of data stored in them. So you can have a number here, but maybe a character, actually probably a factor here, and a factor here. He does say that each column has to have only one mode, but you can put columns of different modes together to form a data frame. And because data frames are close to what analysts typically think of as data sets, we'll use the terms columns and variables interchangeably. So you can call a column or a variable. Now he says if you want to identify elements of a data frame, you can do it in various ways. Here's one way. So this will produce what? Now we did it this way, and then we can later in our class we did it this way. So this was a way to access an individual column, but when we do that, we see that we get a vector. So the output of this is a vector. We're using this $, using the variable name here, and the data frame name here, produces a vector. But he also says you can do it this way. So here's the data frame name again, but here we're not using a $, and the column name. We're doing it like this. In that case, we don't get a vector as the output. This is not, here's the output here, and it's not a vector. In fact, I think we tested this, and we saw that it was a data frame. So if we said, what is, if I assign this whole thing to something called X, and then I type, so here it is, right? I have the patient, age, diabetes, and status. I make it into patient data frame. I print out that data frame, I get this. Now if we do what he said, if we do that, we get this. I claim that's a data frame, and if you do if you, let's say you do assign this to X and check the structure of X, you see that it is a data frame. On the other hand, if you did it this way, so I assign this to this one to Y, it's not going to be a data frame. str of Y will not be a data frame. It's just a vector. Okay? So that distinction is important because the type of object that something is will affect how you can use it. And oftentimes you'll get some error because you're using something of one type in a different way, or you're trying to access different parts of it, but you can only do it if it's one type. You have to access it in one way, and if it's another type you have to access it in another way. Okay, later on we talked about using the table. So that's going to tabulate your data, and if we did it with just one variable, it would count how many cases there were of each of the levels of a particular variable. For example, for example here I did table on age. Now if you look at age, it was 25, 34, so there are no repeats here. So there are four different possibilities, and one of each. So that's what it gives you. If there were repeats, if the 28 had occurred twice, it would say 2 here. Now he does it here using two variables, and then you get a table, you get the possible values of the first variable of diabetes across the top, across the rows, and the second one, the possible statuses across the top. Okay, and you get a count. So this 1 again means that there was one case of, that is one row in our data set. I guess it's one person, because our data set is probably of people or patients. So one person who was excellent status and of type 1 diabetes. Okay, and so on. So it tabulates it. Okay, let's stop and go into another one.